students. Today we are going to discuss about significant figures in a number. Okay students, what is the value of the mathematical constant pi? That is the question first. So I will take the symbol mathematical constant pi. So it is equal to 22 divided by 7. You take a calculator and you find this ratio 22 by 7. What is the value? Let us see. So it will be 3.142857 and 143, and it will be recurring. So many digits will be coming. So if you try to divide this number using your memory with a pencil and a notebook, so many digits will be coming. But you ask a question to yourself, should we remember all the digits? Are all the digits following this decimal are having any significance? No. So what do we assume? This is nearly equal to 3.14. So all the digits beyond this 4 are not certain. They are not at all certain. Means they are uncertain. They do not have any significance. So only 3 digits, namely this 3 before the decimal and 1 and 4 after the decimal, are having some significance. Okay students? And out of these 3 digits also, the digit 4 which is at the end of the number is not certain, it is uncertain. With that or without that also I can write depending on the value of the previous number. So I can round up this number to 2 digits also. So only the first 2 digits are very certain and the third digit is uncertain. Okay, so this is only the definition of significant figures. So what is the definition of significant figures means? It is the number of meaningful digits in the number. First of all, number of meaningful digits. And the definition of significant figure also can be taken as the number of certain digits. Okay, in addition to the first uncertain digit. So all the 3 digits are having significant figures. So I can say that the total number of significant figures is equal to 3. So here this number is having 3 significant figures. Okay, one more example for you. I will take the Planck's constant. Okay, so Planck's constant. The symbol for Planck's constant is H. So this H is equal to 6.625 I will take. Okay, 6.625 into 10 to the power of minus 34 joule into second. You can see the base number is 6.625. So the first digit 6 is having significance. It is certain. And second, after decimal, this 6 also is certain. And this 2 also is certain. But the ending number 5 is uncertain. So including that, all the 4 digits are having some significance. So this number is having 4 significant figures. So the number of meaningful digits. Like that, the total number of significant digits or meaningful digits in a number only are called significant figures. So what is the velocity of light? Actually Michelson did an experiment and found that it was 2.975925, again 275. Many digits were recurring. But don't we assume it as 3? Only 3 into 10 power 8 meter per second we say. All the digits we have neglected. So every number, whenever you handle the numbers in mathematical calculation or solving physical problems, we have to take care how many digits are meaningful, and we have to consider only the meaningful digits. Okay, now we are going to discuss some rules to find out the number of significant figures. So what are the rules? Let us see now. There are some rules to be followed to find the number of significant figures in a number. So first rule is all the non-zero digits. Okay, all the non-zero digits are significant. They are all significant. So this is the first rule. Say for example, one number is 1, 2, 3, 4. So it is 1234. In this number, all the 4 digits are certain and meaningful. So the number of significant figures in this number is 4, because all the digits are non-zero digits. Okay, Now what will happen if some zeros are coming in between? Okay, so all zeros between, okay, all zeros between non-zero digits or non-zero numbers, okay, all the zeros between the non-zero digits are also significant. They are also significant means what? They have some significance. Say for example, in the same number, I will take 1, 2, 0, 0, 3, 4. So this is 1,20,034. Suppose if you remove any one of these zeros in between, then the value of the number will change. So they are safely placed between the non-zero digits. So here 1 and 2, they are non-zero digits. 3 and 4, they are also non-zero digits. And the middle zeros, they are occurring between the non-zero digits. So they have significance. So if you count the total number of significant figures, this is 1, 2, 3, 4, 5 and 6 significant figures. Okay, so this is having a 6 number of significant figures. So these are the first two rules. You can consider it as one set. Now we are going to consider another set of 3-4 points together. Okay, so the next set of points we are going to see here, that is the third one. Okay, the third rule. Now the third, fourth and the fifth point, they are all based on the zeros occurring at the end of a number. For example, if I say the number 1000, 1 followed by 3 zeros. 15,000, the number 15 is followed by 3 zeros. These zeros which are coming at the end are called as trailing zeros. So I will write here first trailing. Okay, trailing zeros. Trailing zeros means zeros at the end. Zeros which are occurring at the end of the number. Trailing zeros. Based on this trailing zeros, we are going to study the 3 rules. So first, trailing zeros, I will take trailing zeros without decimal. Okay, trailing zeros without decimal point. So at the end, okay, without any decimal point at the end. So these trailing zeros, for example, I will take 3, 0, 7, 0. So totally how many digits are there for this number? There are 5 digits. And now the first 0 is appearing between a non-zero digit 3 and another non-zero digit 7. So according to the previous rules, this 0 appearing between 3 and 7 cannot be removed. It is having significance. But the question is whether the last 2 zeros called the trailing zeros, do they have any decimal point at the end or anywhere? No. Therefore, this number is not having any decimal, means the finally ending zeros or the trailing zeros are not significant. Keep it in mind. So I have written trailing zeros without decimal point, okay, are not significant. They are not significant. So you can tell me now, if they have no significance, means then this number is having how many significant figures? 1, 2, 3. 3 only. So I will write this number is having only 3 significant figures. Okay. Now the same case I am going to consider in a different way. These trailing zeros, okay, with decimal point. That is the next rule. Okay. Trailing zeros with the decimal. Okay. With the decimal point. So I can take the decimal point anywhere. Anywhere I can take, but I will write this 3, 0, 7, 0 point. So 0.0 may be there or 0.1 may be there, but trailing zeros means after the zeros, one decimal is appearing, and after that no number should be there, is it not? So this is trailing zeros with decimal point, means now beyond these ending zeros there is one decimal. It is going to safeguard the zeros. So these 2 zeros at the end are having significance. That is the difference between rule number 3 and 4. So trailing zeros with the decimal point are significant. This is very important difference. You should take care. So they are significant. That means this number is having 1, 2, 3, 4, 5, 5 significant figures. So this is the difference between the previous example and the example with the decimal point. Okay, now one more rule similar to this we are going to see, that is the rule number 5. So the trailing zeros instead of decimal, okay, the trailing zeros followed by unit. So followed by a unit or measurement, unit or any measurement. Okay, this is extremely important to be remembered. See here. Here there is a decimal point at the end of the trailing zeros. Now the same I am going to take a 30700 meter or kilogram or centimeter. Any unit is following the number means it is equivalent to that of a decimal point. That means the ending zeros or the trailing zeros are 100% significant. This rule most students are forgetting. Take care. Understand? So if the number is followed by a unit means, or if the number is followed by any measurement means, any number of zeros at the trailing zeros or the end zeros, no, they are all having significance. So I am going to write trailing zeros followed by unit or measurement. Okay, they are also significant. They are also significant. So you count now 1, 2, 3, 4, 5 significant figures. So this is also having 5 significant figures. So the 3 rules based on the trailing zeros you remember as one set of points. See, whenever you prepare, the first 2 rules you call it as first set, and 3rd, 4th and 5th are based on trailing zeros. Is it not? Okay, now I am going to consider the next 2 rules. Rule number 6, let us say. So rule number 6. So for this, once again I am going to consider a number with the trailing zeros with decimal but in a different form. Okay, so numbers with decimal only I will consider. Okay, in numbers, okay, with the decimal point, numbers with the decimal point. In these numbers with the decimal point, zeros before the decimal, zeros before and after decimal, zeros before and after decimal point, okay, after decimal point are significant. This is very important. They are all significant. For example, I will take a 40.00. So this is a number having a decimal point as well as trailing zeros. In addition to that, in front of the decimal also there is one 0. This 0 in front of the decimal point as well as the 2 zeros after the decimal point, all are having significance. All are having significance. So naturally, if you count 1, 2, 3, 4, the number of significant figures must be 4. Say for example, if there is no decimal point, what should have been this number? 4000. 4 followed by 3 zeros without decimal point. This rule we have to follow. Without decimal point means only 4 is meaningful. All the 3 zeros are not significant. So 4000 is different. 40 is different. Only 40 if you write, it is having 4 and 0. It is also having one significant figure. But 40.0 or 40.00 means the number of significant figures are different. That is very important. So this is one of the rules. Now rule number 7 is exclusively for numbers less than 1. Rule number 7 is for numbers less than 1. So I am going to consider numbers less than 1. So less than 1 means it is 0.9, 0.5, 0.75 like that, any number less than 1. So I am going to consider numbers less than 1, zeros, okay, zeros on the left hand side of a decimal, okay, the left hand side of decimal and right hand side of decimal, okay, but to the left of the first non-zero digit. You have to take care of all the points. I have written, see here, three informations are here. What are the three informations? Some zeros may be to the left hand side of the decimal. Some zeros may be on the right, immediately on the right side of the decimal. And those zeros must be what? To the left hand side of the non-zero digit. See, I will write first the example. See here, 0.00567. Is it less than 1 or not? You tell me. The number is 0 point something means naturally it should be less than 1. Okay, how many zeros are appearing to the left side of the decimal point? You see here 1 0. Then how many zeros are on the right side of the decimal point? 2 zeros. These 2 zeros are on the right hand side of the decimal. Are they also to the left hand side of 5? You tell me. These 2 zeros are on the right side of the decimal point, but also they are to the left side of the number 5, which is the first non-zero digit in this number. Okay, so these zeros, I have written zeros on the left side of the decimal point and RHS, right hand side of the decimal point, but to the left of the first non-zero digit. Okay, they are not significant. They are not significant. This is also to be remembered. They are not significant means, so these 3 zeros are not significant. So this number is having only 3 significant figures. 3 significant figures. And the last rule number 8 is common. Okay. So the number of significant figures does not change with the system of unit. Sometimes we express in centimeter or millimeter or kilometer and meter, but the value should remain the same. And the number of significant figures does not change with the system of unit. So significant figures, that is a number of significant figures. Number of significant figures, okay, do not or they does not change with the system. Change with the system of unit. Okay, system of unit. So for example, I will write distance is equal to, for example, I will write 275. Okay, 275 centimeter. 275 centimeter. For example, I have written. Now I want to express this into meter. So centimeter into meter when I want to express, so I should divide it by 100. So I want to divide this by 100. So the same value in meter if I will write means it is 2.75 meter. Is it not? In 275 also 3 significant figures are there. And 2.75 meter also there are only 3 significant figures. Now once again, if I will divide this number by 1000, can I also express this in kilometer or not? Okay, I will do it. So this is now also equal to 0.00275 kilometer. So the choice of the system of unit is ours. Centimeter, meter, kilometer. Understand? So whenever we express in different systems of unit also, the given number should have the same number of significant figures. Okay, to summarize, what is meant by significant figures of a given number? The number of meaningful digits in a given number, or the number of significant or certain digits and the first uncertain digit in a number. Together is called the significant figures. Okay, now what are the rules we have studied in a fast flash? So rule number 1 is what? All the non-zero digits are significant. What is the rule number 2? All the zeros between 2 non-zero digits, they are also significant. Now rule number 3, 4 and 5 exclusively, they are based on the trailing zeros. The numbers in which the zeros are occurring at the end. They are called as trailing zeros. And in trailing zeros together you have to remember as one set of points. That will be easy in your memory. First one is trailing zeros without decimal. Second one is trailing zero ending with a decimal. Third one is trailing zeros ending with a unit of measurement. So if the trailing zeros okay, without a decimal means the zeros at the end do not have significance. Next one is what? The trailing zeros with a decimal point means the ending zeros have significance. And rule number 5 is the same trailing zeros followed by a system of unit or measurement. It is also significant. And rule number 6 is the decimal numbers. Okay, decimal numbers greater than 1. Greater than 1. So this is 40.00. Here the 0 to the left hand side of the decimal as well as the right hand side of the decimal, both are having the significance. And the 7th rule is exclusively for a number less than 1. In those numbers, the 0 appearing to the left side of the decimal and the zeros appearing on the right side of the decimal and to the left side of the first non-zero digit, they are not significant. Suppose if this number 0.00, then 5 followed by 2 zeros, then 6, 7 means beyond 5 and between 5 and 6, those zeros are significant, is it not? So learn the rule thoroughly. So the zeros to the left side of the decimal and to the right side of the decimal, but to the left side of the first non-zero digit, they are only not significant. And the last one is the number of significant figures does not change with the system of unit used. Have you all understood? Okay, bye.